Hello, my name is Uwe Artmann. I'm CTO of Image Engineering. IEEE-P2020 is the standard for image quality in automotive systems. It's the first international standard in this topic. So how can it help you? Let's have a look at that. So flare is in principle light that hits the sensor but does not originate from the corresponding position in object space. That sounds complex, but what it means is like you have stray light or you have some light from the side from the sun, and that causes a signal even though the sun is not even in your field of view. So you have your car, you have a camera behind the windshield, and then the sun from high above shines onto your camera, and that causes a signal, even though the sun is not in your field of view. And that's what we call flare, or that's what we would like to characterize. So there's a different approach how you can do that. So in the standard, there's one that is more closer to the ISO standard, where you have a bright white area and then black dots on top of that. But I think the most or the more interesting measurement that is defined here in P2020 is the flare measurement, where you have where you scan through the entire hemisphere and then change your camera. So you can do that by either changing the position of the light source or by rotating the camera. But what you need is a bright light source with collimated light or from different angles. So you see in the upper left an example of a measurement we did in our lab of a camera where we used a very bright light source, which is actually required to do so, that you need a proper bright light source, because if you want to check the flare behavior for a car, the typical flare light source that you have in the car is the sun. So you need a very bright light source. And as you see in the lower left, it's defined, you need collimated light. So you need to project one bright dot from with collimated light. And in the upper right, you see that the collimated light beam that we create with our flare light source, we actually had to make some dust and in the room so that you can actually see that. So you see over the entire length of the lab, several meters, it's exactly the same shape. So that's a very nicely collimated light that can then be used for the measurement. So that gives you also a map, but the map is then about the different angles. So you rotate the camera for the entire hemisphere, and that will give you then information at which angle you got more flare and at which you got less flare. So from that you have the chance to investigate further what might have caused the flare in your camera.